One of the reasons that we prove these theorems is it helps us understand why they work, and then hopefully it ingrains in our brain a little bit more what the theorem is in the first place. So the isosceles triangle theorem states that if we have these two sides here that are congruent, which actually tells us that it's isosceles, then we know that the base angles, in this case angles B and C, are congruent to each other. Now, I'm going to use this triangle down here to prove this fact. If we're going to prove that those angles are congruent, well, we're going to do a little trick here where we're actually going to construct two congruent triangles by splitting angle A down the middle. So what I'm going to do is go ahead and call this point M here. And so we're going to go ahead and say that AM is a bisector of angle A. And there's no rule behind this. There exists a bisector of it. So this is just by construction. I made it. Cool. So based off that, we know that this angle here has to be congruent, and I'll use 2 marks here, to this angle here. And that's just by the definition of a bisector. So I'll go ahead and note that here. Maybe number these out, actually. That was the first, and that was just a given. Then I've got 2 and 3 here, just in order. Again, just listing out my reasoning like I'm making an argument with someone. And then the last thing is we're just looking for things that are congruent between triangle 1 here and triangle 2. And you know what? They both have this same side here, this one that I constructed, that's congruent to itself, right? And so this might seem a little silly, but in a formal proof, we would actually have to make note that AM is congruent to itself, and that is by the reflexive property. Again, if you left this out, it's technically wrong, but it's that one's pretty well understood. That's not a huge issue with the logic there. And actually, at this point, hopefully we realize that we're done. If we think through the different properties of proving that triangle 1 is congruent to triangle 2, and we'll talk about why I'm doing that in a second here. Well, here I have a side and a side, an angle and an angle, and another side. That's side, angle, side. So I know that these two triangles are congruent to each other. I just need to make sure I do it in the right order here. So here's a little trick that I sometimes do. Is I know that these two angles correspond with each other. So with both of them, I'm going to start with angle A, or with point A. And then I see that they both have these congruent sides here. So I'm just going to travel along there. So if I travel along, and that way I get that congruent piece in between, since these two sides here have to correspond to each other. So I'm going to go from A to B for the first triangle here, triangle 1. And then I'm going to go from A to C for the second triangle. And then both of them finish up at M. And now I know that they're in the right order. And I'm going to make a quick note before I forget. I knew they were congruent because of side, angle, side. I think that one was a postulate. All right. And then the very last thing, always keeping in mind, what was I trying to prove? I was trying to prove that these two angles are congruent. Oh, well, those two angles are congruent then, because if these two triangles are congruent to each other, then all their pieces have to be congruent. And if you notice, B and C line up here. So this is actually just that corresponding parts of congruent figures are congruent. And that's it. I've now proved this theorem. One thing I am going to point out is this actually is a biconditional theorem, meaning that it goes both ways. So if we know that these two base angles are congruent in a triangle, then we know that the triangle is isosceles, so that the legs, I guess I should have mentioned that before, that these are called legs here, are congruent.